I welcome you all to my talk about accuracy evaluation of a CDM-WDM interrogator for quasi-distributed FBG sensing. My name is Marek Götten and I'm from the University of Applied Sciences, Wismar in Germany, as well as from the Technical University of Madrid in Spain. At first, I briefly introduce the interrogation system. Peak detection of reflected light from FBGs is based on a so-called difference spectrum. It is a result of two optical correlation steps, a direct and an inverted spectrum, carried out by two modulators and a spectrometer. The subtraction leads to a difference spectrum that contains only light of a specific part of the sensor network. It is determined by the different optical path lengths for each section. The peak heights in the difference spectrum depends on the light distribution between direct and inverted spectrum, as indicated in the table. To cancel light from other sections, it must be equally distributed between both spectra. Like this, the system can interrogate thousands of sensing points individually that are organized in several identical sections. Within those, FBGs operate at different wavelengths. For static deviations, no strain is applied. Out of 2,000 measurements, the peak wavelengths are determined with a 3-point Gaussian approximation. The wavelength spacing of the spectrometer is around 160 picometers. The sample standard deviation is calculated to analyze static deviations. The lower the peak height, the higher the standard deviation. Static deviations are less than 3 picometers, even for lower peak heights. Dynamic self-interference occurs when the peak in the inverted spectrum shifted spectrally due to dynamically applied strain. Then, the subtraction of two spectra does not work properly and the peak is deformed. A peak detection leads to deviations depending on the actual wavelength shift of the peak in the inverted spectrum. A gradient describes the deviation in picometer per picometer of wavelength shifts. When 75% of light is in the direct spectrum and 25% in the inverted, a peak height of 50% is achieved, which leads to a gradient of -0.8 picometer per picometer. Completely synchronized light does not suffer from dynamic self-interference. For non-synchronized sensors, the light is equally distributed between direct and inverted spectrum. For dynamic multi-user interference, dynamic strain causes a shift of the peak in the inverted spectrum. The cancellation is insufficient and a positive and negative peak occur in the difference spectrum. They superimpose on the desired synchronized peak and lead to deformation of the peak shape. The deviation due to this deformation is, for a peak height of 50%, equal to -1.58 picometer per picometer of wavelength shift between direct and inverted spectrum. For full peak height in the synchronization point, the gradient is -0.5 picometer of deviation per picometer of wavelength shift.